everybody's keeping well in these difficult times. Welcome to the KTN's Open Forum. This is the first of these that we've actually run. Our plan at the moment is to run them every 6 months, but we will be asking you some questions at the end of the session today, so you can give us your feedback, and we really want your feedback. Equally, we'll be asking you some questions during the presentations with some polls, and at the end of each presentation there'll be an opportunity to ask questions. I appreciate 2 hours is quite a long time. We're all having a lot of Zoom meetings while we're sitting at home, unable to do much else, but I hope we can hold your attention and retain your interest for at least that period of time. Okay, just some practical points before we start. All participants will be muted throughout the webinar. Apologies for that, but it's quite difficult to hold a webinar with so many people if we don't do that. But if you look at your screen, and you certainly, if you hover the mouse, you should be able to see a Q&A box at the bottom and also a chat box. If you want to ask questions, please use the Q&A box. One of us will be looking at that and collecting questions. We'll do our best to answer as many as we can. If we haven't got time, or any of you can't answer, we will get back to you afterwards. If you have any technical problems or anything, use the chat box, and again, we'll do our best to help. It is recording this webinar, so if anybody else wants to listen to it, or you want to listen to it again, you'll be able to. And also you'll get copies of the slides sent through, and some of the slides do have links on to useful stuff, so hopefully they'll come through very quickly. And you've already had an invitation through email to register with Meeting Mojo. If you've done, I know some people have already taken the opportunity to do that and arrange meetings with other, well, either ourselves in the KTN or other people who are on the webinar. So hopefully you can get as much benefit as you can from this session. So this is the format. We will aim to finish by 12 o'clock. First half an hour, or hopefully less actually, is from me talking about the KTN in general, how we've responded to COVID, and what we're doing at the moment around funding opportunities. We've then got 3 presentations on three of the sort of main bits of work we're doing at the moment, and you'll hear more about those as we go through. And finally, as a wrap up with future opportunities to engage with us. So what's KTN? Well, first of all, KTN. This is the standard KTN news slide with our current strategy sort of strapline: connecting positive change. And what does that mean in practice? 2 things really. One is we work with industry and academia to help companies, and they may be entrepreneurs, startups, but also medium-sized and large companies through what is a complex challenge of bringing new products to market. So basically helping companies to innovate and hopefully add value to the UK economy. The other bit of the job is supporting UKRI, mainly InnovateUK, but increasingly the rest of UK research and innovation, and sometimes other government bodies, where we're actually sort of helping UKRI to understand where any public intervention is going to have the biggest impact. At the moment, you'll see as we go through, there's a big focus on moving towards net zero, a low carbon economy, and you know, that sounds easy, but actually there's a number of things you could do in order to help industry make that change. And what we want to do is help UKRI understand where its money is going to have the biggest impact. And I guess what we're all after in this is we want a chemical industry in the future that's going to be sustainable, it's going to be resilient, environmentally friendly and aware, but most importantly, it's got to do all that and still make money, still be commercially successful and globally competitive. So it's sounds easy when you say it quick, but it's quite a tricky thing to sort of navigate your way through. We think chemistry and industrial biotechnology have an enormous role to play in helping industry make this change. So we're helping to do this. Also, I would also like to stress that this kind of complements the same message basically that's going up from the Chemistry Council through directly to BASE. So I think we're reinforcing each other and actually trying to sort of find practical ways of making all this this happen. Sorry, my slides are moving ahead without me doing anything. Right, let's try again. Just a few words about COVID-19. How have we responded to it? Well, everyone's set up to work from home now. Many of us did anyway, so it's not made a huge difference. And industry largely is still operating, so we've been able to carry on doing most of what we do. But like this event, we probably might have held this as a face-to-face event in different times. We've now moved all of our events online essentially. So in May, for example, there were 60 online events delivered, and not some of them actually quite complicated. So this is a webinar, so it should be straightforward as long as the slides don't move on their own. But also events where you actually have to create virtual post-it notes on virtual whiteboards, things like that. So there's a number of things we've done that we hadn't really done much of before, and we'll probably continue to do after COVID. So if we're looking for any sort of bright spots in the COVID crisis, maybe it's helped us to do some things that we will carry on doing. We've put in a COVID hub by the website and seen record traffic in April, largely driven by InnovateUK's COVID-19 competition, which I'll mention in a few minutes. And we've had a KTN webcast series with a panel talking about COVID-19 and some of the issues. What challenges have we had? Well, we've had to respond fairly quickly to short-term requests. We've had to develop some forward-looking groups to look at how innovation is gonna not just help us get out of COVID, but help us bounce back quickly. And you'll see later on that there are some things that are happening to help industry do just that. And also a higher volume of queries. And basically looking at how we can respond more quickly to responses. And with I mentioned the Innovate COVID competition that came out, in the KTN, we ended up doing an awful lot of assessments in a very short time for a competition which I think turned down grants to companies quicker than anybody can ever remember. We've also helped to look at some of the immediate challenges mainly around things like, is there any issue with supply of chemicals, reagents, materials that are critical in areas you can see on the screen. And some there were, in many cases, actually there was no supply problem, but it was more a planning and ordering issue where things weren't quite working properly. But nevertheless, we did a lot of work to sort of help understand what the problem was and how we could tackle it. I'm just going to introduce the team, and you'll be hearing from most of them during the morning. As you can see, we're kind of strategically scattered around the UK. Well, not particularly strategically, because it's not that easy for us to get together face to face, even when we can. But if I start from myself, I'm sitting somewhere off the coast of Wales there, with an arrow pointing towards Chester, which is near where I live. So I'm the head of the team, and then going clockwise around, the next is Raj, whose job title, as you can see from the right, is IB, but Raj actually sits at the sort of boundary between IB and chemistry, having done both during his career. Michael, who's up in Cumbria, Michael Burnett, is our process manufacturing person, and particularly at the moment, that's focused very heavily on catalysis, and he'll be telling you about that later. Then going over the other side, Matthew Reeves is in Edinburgh. He's materials chemistry, particularly covering formulated products and plastics. And Matthew will be, you may hear from him, he's managing the Q&A box and the chat box for when anybody has any questions. Catherine Mort in Newcastle is industrial biotechnology, and then going down, Dana Helt, Nottingham, is, well, we're saying synthetic biology at the moment, but I think the name of that is starting to change to engineering biology, but Dana will tell you about that in due course. Then Peter Clark, somewhere in East Anglia, is, it actually, he may be surprised that I've changed his job title because it was raw materials, but actually, given what he's doing now, it's very much around decarbonisation. He still, however, has quite a strong interest in raw materials for the future. And then finally, Sheena, who is based in London. I don't think she's there at this particular point in time, but Sheena is also materials chemistry, but also catalysis and also decarbonisation, whole range of things. So that's the team. Just in case anybody doesn't know, what sectors does the chemistry and industrial biotechnology team support? Because the KTN has a whole load of teams that cover various sectors and various technologies. What we cover is any chemical manufacturers that have operations in the UK, and also what I'd call the chemistry using sectors. Now you could say, well, every sector uses chemicals to some degree, and that's true. So we could say that we support aerospace. We could say that, but I think what we're talking about here is those sectors for which chemistry is a critical part of their business. Pharma is obvious, home and personal care, agrochemicals, and so forth. So we have an interest in supporting any market that uses chemicals, or indeed any market. I mean, if you take energy, that's more, there is a real contact at the moment, because energy is going to be a crucial factor to how we make chemicals going forward. So I'll go through what the current funding opportunities are, and there are some links in here, so hopefully you should get these slides pretty quickly and you'll be able to follow those. Just before I start, I would just make the point at the top there that if you haven't already done it, and if you sign up on the KTN website, which is an easy thing to do, it doesn't cost you anything, and you input your interests, you will get a roundup of current funding opportunities. You can actually see it on the website, but you will also get it in a regular newsletter. And the newsletter will have all sorts of stuff which should be tailored to your interests. So hopefully it'll be a worthwhile thing to do. So that's something that you can do on an ongoing basis. Just a few things that to mention there. For those of you who know about knowledge transfer partnerships, which is a really nice scheme where a company can essentially have somebody from a university, a postdoc, or whatever, a PhD student in some cases, working in their company, but actually employed by the university, and they can have time at the academic. So if you want to get a technology from a university translated into your company, then that's a really good way of doing it. And whilst it says the current scheme closes on the 15th of July, there's going to be another one open the following week. So it's one of these things that you can apply for almost at any time, but there are deadlines that come up. The Bridging for Innovators program is a means of industry accessing the Science and Technology Facility Council's large-scale science facilities around you. So these are things like the synchrotron and the neutron source at Harwell, the high-power computing facility at Daresbury. So if you think that these facilities might possibly help you solve one of your business technical problems, then this is a really good scheme to to give you sort of easy access to those facilities with assistance to do it. There are a number of Horizon 2020 programs still open. Of course, we're still in the transition period, so we can still apply, we can still join these, and hopefully we'll still be able to take part in European programs after the end of this year. But at the moment, just a few things that the community here might be interested in. The SME instrument has, the chemical sector in the UK has had a lot of benefit from the SME instrument over the years, and that there's a call currently open there. There's a couple of prizes. I think that's the European Innovation Council is what EIC stands for. 2 prizes, one for batteries for electric vehicles and one for artificial photosynthesis. So really interesting stuff. And one to look out for in a couple of months' time, we understand that there will be a call coming out through what's called the Green Deal 2020, where there's a budget of about €1 billion available, and there will be a KTN briefing event on the 10th of July. So if you're interested in that, again, there's a link there to click on to register for that briefing event. Other InnovateUK funding programs, smart grants. I think they're in abeyance just at the moment. We keep hearing news or keep hearing rumours that there will be another competition open soon, and hopefully that will happen. So smart grants are the standard InnovateUK collaborative R&D programs. They're open to anybody. They have to have an SME in the consortium, but they're always worth applying to. And of course, I should just point out the KTN is happy to help you put a decent proposal together. We can't write it for you, but we're happy to critique any proposals that you put together and offer you advice, which you can take or ignore, on how to improve your proposal to make it more compelling and more likely to succeed. There are some industrial strategy challenge fund challenges still running, and the 5 I've put in there are the ones that are relevant to this sector. Industrial decarbonisation is an interesting one because there's not going to be, as far as we know, any opportunity for collaborative R&D in that one. There will be some projects with the various regional clusters to help them put in carbon capture and storage facilities going forward, and to develop roadmaps to plan how they're going to tackle low carbon manufacturing in their region. Something that is worth looking out for, though, is IDRIC, which is, well, you can see what it stands for, and this is the low TRL. This is the research bit of industrial decarbonisation. It's led out of Heriot-Watt University, and I think worth watching for what opportunities for funding come out of that. Not just for academics, but possibly for academic industry collaborations as well. But we will keep an eye on that one and inform you either through the newsletter or through the website or directly. Transforming foundation industries. Pete's just put a comment on the chat saying IDRIC will officially launch in September. So there you go. So the Transforming Foundation Industries Challenge, we're still awaiting news on future calls on that one, but that's essentially to enable the big energy users like steel, ceramics, chemicals, to transform how they operate to move towards a better low carbon, more efficient future. So definitely relevant to the chemical industry and worth keeping our eyes open. We'll keep you informed on when the calls come out. Manufacturing made smarter. A lot of focus on digitization in that particular challenge. And at the moment, well, there is a call opening next Monday, on re-engineering supply chains. Smart sustainable plastic packaging. No calls open at the moment, but we're expecting a number of things to happen towards the end of this year, probably opening early next year. And then finally, driving the electric revolution. This is kind of everything except batteries. It's kind of power electronics. It's not just cars, it's every form of transport. So compound semiconductors, things like that. I think it's one that's worth keeping an eye on in the future. There is funding competition open at the moment, closing at the end of this month. So if you're interested, worth looking at that, and we can help if you need help. And a number of COVID related opportunities. I've already mentioned the top one, which had a huge response. Open calls for R&D ideas to address COVID, and that's essentially still open. Proposals can be submitted at any time, and it's kind of open, I think, until the money runs out. There are some others which are the next one is very much around research into COVID, not into the virus itself, into the epidemiology. There's a future fund which is convertible loans. There's a coronavirus business innovation support package, which is something that InnovateUK are offering to award holders whose funded projects have been interrupted by COVID. Again, that's open until the end of the year, or all the money runs out, whichever comes first. And there are plenty of EU grants for urgent research into coronavirus, particularly around repurposing of manufacturing, medical technologies, and digital tools and AI. So there's again some links there that will sort of take you to the relevant places. Okay, this is a big one. It was only announced on Monday, 2 days ago. So we found out about it literally over the weekend, and it's the Sustainable Innovation Fund. It's really to enable industry to bounce back after COVID. The first phase has got 55 million in it, and it's to fund single or collaborative R&D projects. And there will be, apart from medical technologies, there is a strong focus on net zero, essentially, energy, low carbon, sustainability. It's a standard kind of format for collaborative R&D, or it's the same format as Smart Awards, essentially. Open this week, closes 29th of July. In parallel with that, there's just almost identical sort of topic, a sustainable innovation SBRI competition. This is a small business research initiative, which is essentially asking businesses to submit solutions to problems, and in this case, or to challenges. In this case, the challenge being how to bounce back after COVID, what innovation can help industry and the UK bounce back quickly and most effectively. And I think this is the last of my slides, but we'll see in a minute. And I mentioned that energy. If you think about where the carbon emissions come from in most of our manufacturing, actually it's energy use rather than from the process itself. So transforming how we use energy in the industry is actually a pretty crucial thing if we want to move towards net zero. So there is a new fund. Again, this hasn't quite opened yet, but it's going to open in a couple of weeks' time, 3 weeks' time, and it'll help business with high energy use transition to a low carbon future. Open to individual manufacturing sites and data centres in England, Wales and Northern Ireland. Scotland, for those of you in Scotland, you will get some money, but the Scottish government is saying, give us the money and we'll run it in a separate process from the rest of the UK. So something will run in Scotland that looks very similar. So phase one is feasibility and engineering studies for potential deployment projects delivering energy efficiency or deep decarbonisation benefits, and mature energy efficiencies to improve process energy efficiency. Briefing events, 14th and 20th of July, so a link to those. Okay, and I think that's where, at this point, I hand over to Peter Clark, who's going to take us through the next phase, and he should have control of the screen now. I hope he has.
Good morning, everyone. Let me just test my slides. Okay, looks like it's working. Good morning, everyone. Yeah, I'm going to tell you a little bit about some of the work we've been doing It's very much related to the challenge of getting to net zero. We're coming at this from a particular angle. We're trying to answer this big, meaty question: what are the feedstocks we're going to be using to produce chemicals in 2050? I want to use this session to introduce you to this work that we've been doing, to get your feedback, but just recognize that this is part of a journey and that we're planning lots of other activities to spur this on this year, but really keen to get your initial feedback. Taking a step back, net zero is certainly a popular term at the moment. It's going to be a key driver for innovation in the UK and globally, of course, for the next, well, until we get there. But let's take a step back. What do we mean by net zero? This is about us reducing our impact, reducing the impacts of climate change. In the UK context, it's about us ensuring that we can meet our obligations under the Paris Agreement, which is about limiting global temperature rise to below 2 degrees below pre-industrial levels, and actually ideally pursuing efforts to limit it to below 1.5 degrees below pre-industrial levels. It's a big target. This just shows the different pathways depending on which trajectory you're looking at. The UK took a leadership position. It was the first major economy to announce actually net zero targets. The CCC, the Committee on Climate Change, recently put out just last week their progress report to Parliament to track how we are going. And actually, you know, in the period 2008 to 2019, our overall territorial emissions reduced 30% while the economy grew 15%. And this is something that, you know, people have been worried about in the past. I don't think it's so much an issue now, but this fact that, you know, can we grow whilst also reducing greenhouse gas emissions? Yes, we can. I'd just say the interesting thing about thinking about net zero is actually the quickest way for UK to get to net zero is let's just not manufacture anything here in the UK. Okay, that'll get us to net zero because we're only looking at our territorial emissions, but then we'll be importing everything. Okay, that's not the future we want. So just to make that point. So the Committee on Climate Change have done a huge amount of work looking at how the heck we're going to get to net zero by 2050. It's complicated, and they've looked at each sector. They've looked at specific areas of the economy where we're going to need action. And here's a summary of where they think, you know, we're going to need actions in the next decade and in the 2030s and 2040s in order to get to 2050. I look at these challenges around hydrogen, around greenhouse gas removal, around the future of road transport, waste, the future of F-gases, the future of biofuels, and all that I see, biased, as I think you are, hopefully as well, you're agreeing with me, that actually there's huge number of challenges and opportunities that we in the chemistry, industrial, biotech sector, where we can bring the solutions. So I think it's really exciting to have net zero as a target in the UK. And let's see how we can use our skills to impact and contribute to this. This morning, I want to focus on a very particular lens. I want to focus on how are we actually going to be making chemicals in 2050, thinking towards that future. Now, how do we make chemicals? Incredibly simplistic view. There's a feedstock, you do a number of processes, and you produce a product. I'm going to be focused really on the first step, the feedstock and sort of the primary conversion. There's a huge amount of opportunity for us in the chemistry, industrial, biotech community to be thinking about the products that we're going to make and thinking about how much of an impact they'll have on net zero. There's a huge amount of innovation we know in terms of processing technologies that can contribute to a lower carbon footprint. But at the moment, I'm going to focus on feedstocks. And I want to paint you a scenario. In 2050, scenario one is actually very similar to the scenario that we have today. So currently today, around 90% of organic chemicals are produced via the petrochemical supply chain. And actually, maybe, and let's take scenario one, in this scenario, we'll continue to do that. Maybe that will continue to be able to happen because we'll have invested in energy efficiency, we'll have invested in carbon capture and storage, direct air capture. In fact, maybe that is the best way forward. Maybe we'll continue to utilize the same supply chains that we have done. Maybe. And actually, if you think about a barrel of oil, so around up to 15% of a barrel of oil goes into petrochemicals. The remainder, the majority, goes into transport fuels and waxes. Now, the market for transport fuels, for road transport fuels, let's assume that's gone in 2050 or largely gone. So does that mean we now have access to even more of that barrel of oil, and actually it's even cheaper? So maybe scenario one is what we'll end up with. Scenario two, in scenario two, crude oil is no longer acceptable to be dug out the ground, period, for any purpose whatsoever. Or actually, if you want to think about it in a different way with a UK context, think about it in this way. Think about it that actually it will be no longer economically viable or environmentally, socially viable for us to be taking petrochemical feedstock that we import and processing it in the UK. Either way, I'm painting the picture that we're either importing all of our chemicals or we are manufacturing from alternative feedstocks. What's the future going to hold? We don't know. I don't think there's enough, the picture is unclear. I certainly think that by 2050, if we've not thrown out the linear chain that I showed you before, we're in big trouble. This is about, yes, it's about moving to net zero, but if we haven't embraced a more circular economy by 2050, we're going to be in serious trouble and miss out on serious opportunities. So I think the future is definitely, for a number of reasons, in terms of security of supply, in terms of thinking about new supply chain opportunities, we must be looking at new supply chain opportunities based on these alternative feedstocks. There will still be a role to play, I do think, for petrochemical refining assets. If you do look at the UK Petroleum Industry Association's vision for the future, actually, they actually recognise that actually the future of petroleum assets is taking in a lot more recycled content. So I think actually this is, we're looking at a more circular future in terms of feedstocks. The important thing that I want to look at here is what can we do with the alternative feedstocks here in the UK and look to drive that forward. So back in 2017, the chemical sector, what's now called the Chemistry Council, and also BEIS, together with other industries, were plotting a future to net zero, and they put out a report called the Decarbonisation and Energy Efficiency Action Plan. This was a joint industry government report, and as one of the actions that were included in that action plan, as a result actually of some work that SCI did to look at what are the sorts of technologies we're going to need in the future, there was an action in that plan that said we should really need to understand the capabilities that we have in the UK in order to help us enable a net zero future for the chemical sector. And that's why we've done this next piece of work, which is really, we've taken it through a particular lens of saying, let's understand the capability we have to look at bringing on alternative feedstocks of chemicals. And what we've been doing over a period of around 9 months, 9 to 12 months now, is we've been doing a desktop research and also interviewing experts. And we've been trying to understand the capabilities we have in the UK in terms of our R&D capability. So our capability within academia, within the key academic centres, hubs and networks, also the capabilities we have on scale up in our research and training organisations or within academia, and then also our innovator community. And we've been doing all this work to really try to map out and understand, so where do we have capability, and then where do we have strengths? And what we've done is we've put all of this data and done all of this analysis, and we've put it into what we're calling a capability map. You might have seen us in the past, we've put out a number of sector-based landscape maps, and I think Dana and Catherine are going to mention some of those later. What we've done is we've taken this a sort of step further here with this capability map, and you can access it via this link. And we've put all of these organizations that have capabilities in the alternative feedstocks to chemicals space, we've put them into this map, and we think we've designed it in a way, we hope, that is accessible for you as an innovator who might be interested in this space, to identify potential partners. So please go on, use that tool. It even analyzes, where we think the current innovators are at in terms of their technology readiness level. And we want this to be a tool that helps spark ideas on where we can move this agenda forward. But importantly, what this work has also done is really help us to understand where we think there are strengths and opportunities for the future. So this is where we think we need to be concentrating our efforts. And I'm going to talk about 5 key areas at a very high level. The first one is carbon capture and utilization. So we have a number of innovators with expertise in the capture part and the utilization part. We have fantastic academic capability in this space as well. We're also looking at a future where hydrogen is potentially, we've got fantastic innovators in the hydrogen space, in the electrolyzer space. We also are world leaders in things like offshore wind, which may provide us with an opportunity to access green hydrogen. And there's also a number of clusters looking at a future with blue hydrogen centrally as well. We think this is going to be a key area where we need to develop different technology opportunities. When we look at the different ways that innovators are looking to take care of solid waste, be that municipal waste or plastic waste, syngas is coming up as a key vector. So there are a number of companies at the moment, commercial, pre-commercial, that are looking to perhaps gasify these waste streams and produce syngas. And there are a number of interesting projects in the UK that are looking to use that syngas as an energy product, as a fuel product. That's fantastic. We need those projects. But what we want to spur on is, let's think about whether we can use this syngas as a feedstock to produce chemicals. The third area is, what about if we look at how to take the innovation that's already been done actually to produce low carbon fuels. So I'm thinking about the companies that are already here in the UK that are producing bioethanol, biobutanol. They're currently serving a road transport demand. That's important. We need that. We probably need more of that in a relatively short to medium term. But perhaps that market will decline over time. So what are we going to do with them? When I look at them, I look and think they have low carbon green molecules. And I'd like to look at how we can commercially viably transfer those molecules and put them back into the chemical supply chain. We think that's another opportunity. Fourth is biomass valorization. We have fantastic capability within the UK academic infrastructure. We also have actually quite a bit of scale-up capability here in the UK through our RTOs, like the Biorenewables Development Centre, like CPI, like Beacon. And we also have a number of innovators that are doing some great stuff in this space, actually, that are quite well progressed. So we think that there's some real opportunities here. We think we need to do more here. The fifth one is plastic. You know, it's one of there's a huge focus on plastic at the moment, and actually chemistry and industrial biotech will play a key role in producing non-petrochem based versions of that material, but also in making it a recyclable circular economy material. So these are the 5 key areas that we think are important. We are now working up a plan in which we're going to develop and help understand where are the market opportunities in the UK. And we think actually the market opportunities are going to come from understanding the local, the regional opportunity. What I want to do now is try to make the content that's in that capability map and what I've just said kind of real. So I'm going to give you now 3 examples of fictional projects where we need to join together these different technologies, where we need to be thinking about producing chemicals of the future. They're fictitious, but actually, because we know the map inside out, we can point to companies and organizations that could have a role to play in these projects. Fictitious example 1, we have an abundance of offshore renewable energy in this site in the UK. We also have a local council, a local municipality that wants to do something with its plastic waste beyond incinerating it. Well, that's great, because actually we've got an innovator here in the UK that can produce a lovely, clean syngas. Now, perhaps they're going to use it to heat homes locally, which would be also very beneficial. But actually, we've also got a local airport that's screaming out for some sustainable aviation fuel. And that's okay, because you know what? We've got another innovator who's got a catalytic technology who's going to take that syngas and produce sustainable aviation fuel. This is looking good. This is exciting. This is the sort of new supply chain we need in the future, need in the UK. But in a net zero future, this thermal conversion technology to produce the syngas is producing CO2. What are we going to do about it? Okay, well, in this scenario, actually, down the road, we've got a concrete manufacturer, and actually, they'd love to have a low carbon material that they can put into their concrete. And again, that's okay, because we've got an innovator here in the UK we do have a number of them, that can take that CO2 stream. And actually, if there's also the right other feedstocks locally for the carbonation technology to work, we're going to be able to take that CO2, capture it, and convert it into a material that can be used locally for local infrastructure projects. Example 2, in this example, I'm going to put us in an industrial cluster of the future. And in this industrial cluster of the future, we've got a lot of blue hydrogen, which means we've also got access to a carbon capture and storage network. We've also got a big issue with municipal waste. And again, we want to look at a higher value recovery opportunity other than incineration. And again, we're going to look at syngas as the initial vector here. But instead of making a low carbon, sustainable aviation fuel, we've actually got a local chemical company who is desperately searching for a low carbon route to a certain chemical. And actually, we've been able, during the 2020s, to pump in some money and funding into development of novel catalytic technologies that are able to take the syngas and produce a chemical that is suitable and fit for that chemical supply chain. But you know what? Again, we've got that problem of CO2. In a 2050 world, it's not going to be acceptable to release that CO2 to atmosphere. But okay, maybe we're in this industrial cluster. We have access to a carbon capture and storage network. So we'll work with a carbon capture and storage. We'll work with the network. We'll put it into the network and it'll be permanently sequestered. Okay, maybe that's going to be commercially viable. Or maybe we've pumped some money in the 2020s to look at an alternative valorization opportunity. And maybe this is just a sweet spot for biocatalysis to produce a fine chemical for a local chemical manufacturer. The third example, you'll be pleased, does not involve syngas, to show you this is not all about syngas. In this example, we've got access to biomass. Maybe it's local biomass, maybe it's imported biomass. But we are producing, we've started off our life as producing a biofuel, maybe for the road transport market, it's biobutanol, it's bioethanol. And that's great, but actually as part of our process and thinking ahead to 2050, we're also producing CO2 and hydrogen. And we demand that we have a more circular approach. We demand that we're not releasing CO2 into the atmosphere. What are we going to do with it? Okay, well, maybe we're going to work with our innovators in the carbon capture sector, and we're going to look to take off the carbon dioxide and separate the hydrogen. We're going to use the hydrogen to lower the carbon dioxide footprint of our process, and use that for heat. And we're going to take the carbon dioxide, we're going to capture it, and we're going to give it to someone who wants it. Or maybe in the 2020s, because we've been putting some funding into this space, we've actually got a really groovy electrochemical transformation that's just suited to this sort of scale and this sort of purity of gas stream. And actually we're able to put this into the chemical supply chain. These are the sorts of projects we want to see bringing on in the UK. We see the beginnings of projects elsewhere, whether it's in Antwerp with the Innovate project looking at methanol, whether it's Iceland, again, looking at methanol, Netherlands and Denmark working on producing low carbon fuels. We need to be looking at this in the UK. But to realize this opportunity, and this will be echoing some of the things I've already said, we're talking about creating brand new supply chains, and we must be careful that we're going down a more sustainable pathway. And we also must be careful that we're creating value for each point in the supply chain. So we need funding that's going to allow us to explore that. We need funding that's going to identify for chemical sector which molecules to make. We need funding that's really getting to the heart of this local opportunity. We need to be working closer with our industrial clusters and with other local operators to really find out how these different technologies come together. And it is exactly about the different technologies coming together. In the scenarios I've shown you, there's no single innovator that has the silver bullet solution. It requires them to work together. That's what we think. So I want to pause there and I want to ask you what you think about what I've just told you. Are we crazy? So there's now going to be a Zoom poll that's put up for you. And this is the question I want to ask you. Do you think we need further intervention to develop these new local alternative feedstock supply chains for chemicals? And I think I've given you 5 options. The first one, no, don't bother, Pete. This is not where we should be playing. It's not a priority. Let the market sort it out. okay, please tell me if that's what you think. That's very important feedback. Or the next three answers are around, yes, I like what you're saying. I think this is important. We need funding. And then I'm asking you to tell me sort of where you think the funding is most required. Is it across the TRL spectrum? Is it late stage? Is it early stage? Or actually the last one is, Pete, you've blown my mind. I really don't know. That's fine also. So I'm going to allow you a bit of time to answer that. I'm not just going to pause for maybe 20 seconds for you to answer this poll. I'm just keen to see the immediate sort of feedback. And I'm hopefully going to be able to see that answers to that poll when it comes in. So Matthew's telling me we've had about 60% of the votes. I'll give you 5 more seconds and then we're going to check the answers. Okay, so I'll leave it there. Shelley, are you able to share the results with us? Interesting. Okay, so that's very useful feedback. A couple of you maybe said not important, leave it alone. But a majority, I think, is saying yes, we need it and we need funding across the TRL spectrum. A number of people saying demo and a number of people saying feasibility is important. So thank you. That's very useful feedback at this point in time. Hopefully I have controls again now. Oh, hello.
Okay. Well,
sorry. I'm back.
Oh, we have trouble with these things, don't we? Thanks, Pete. It's Steve here again. So we've got.
Sorry, I just going to say, keep an eye out for further announcements.
Oh, sorry. Go on. Yeah.
Keep an eye out for further announcements about our activities. We're planning to accelerate this area in the future. Review our map. Get in touch with us with feedback on the map. Get in touch with us with feedback on projects and ideas. If you want more background on this area, have a look at the articles that we recently released. This has been a joint piece of work, very much in collaboration with my colleague Sheena, also my colleague Catherine Mort, who's been feeding in on the industrial biotech side. That's all. Sorry, Steve.
No, sorry to interrupt. Right, okay. Many thanks, Pete. I notice that we've got, actually, we've now got one question seems to have appeared in the Q&A box, but there are quite a few questions, I think. But actually, the chat box has been used a lot, which is great, because this is the best we can do, given the fact that you can't go and mingle over coffee like you would if this was a live event. So there may be one or two questions in the chat box, but I'm glad that people have been introducing themselves to each other and to the rest and to the group, which is fantastic. I was just going to ask Matthew if there are any sort of questions that have popped out in the chat box that we can
yeah,
do in the next 5 minutes.
Yeah, there's been quite a lot of good conversation around this, quite a good number of comments. There's one comment that's been put in the Q&A box that I'll just mention. So it's from Sheetal Handa at BP, saying about the catalysis is going to be key for almost all of the transformations and processes that you've covered, Peter, and just emphasising that we need funding for this so we can use the range of feedstocks that are available. There was a question in the chat box from Brian Taylor asking about whether aviation fuel could be produced by a transesterification approach similar to biodiesel. That's something else potentially to look at. And yeah, a lot of good comments in the chat. I'm sure we'll be able to follow up in the meantime, but no direct questions per se.
Okay, thanks, Matthew. I mean, yeah, I think there are opportunities to look at sustainable aviation fuels via those alternative mechanisms. I think there are already approved routes for aviation fuels via those sorts of alternative pathways that I think Ryan mentioned. Sheetal's question's very good because it was a perfect lead into what Michael's about to say actually on catalysis. So catalysis actually, yeah, when we look at the transformations required, catalysis is absolutely critical, but I'm not going to steal any more of Michael's thunder because I think he's about to really demonstrate how much of a role it plays. Matthew, I've seen another question pop up, but how are we doing for time? Do we want to pose any more questions?
We're okay for a couple of minutes, I think. But I noticed that Jeremy Shears put up a very appropriate comment that actually, yeah, we need legislative as well as fiscal incentives for low carbon chemical. Absolutely right. And the fact that at the moment the molecules go into biofuels, as you know, there are incentives to do just that.
That's it, and there's no incentives to take these molecules into the chemical supply chain at the moment. Yeah. So it's without that, it's difficult to create the business case, isn't it? To be honest.
Yeah, and also Jeremy mentioning or asking about any relevant work on assessing the carbon and energy efficiencies of all these various processes, but perhaps that's not up to us to do. Maybe that's for research groups externally to do that.
Yeah, it's really important, isn't it? Because we may find that some of these routes are actually not any more sustainable than the petrochemical based version. We don't, so we do need life cycle assessments are going to be key into understanding what really the benefits are. So as part of any sort of project moving forward, that's going to need to be done early. Would be my view.
Yeah, I think there are some other questions in the question Q&A box as well, which might be more appropriate for some of these to pick them up separately, but interesting, you say Sheetal says catalysis is going to be key for all these transformation processes, which I think probably leads us quite nicely as a link into the next presentation, because that's actually what this is about. And so at this point, hopefully, we can get the control of the screen handed over to Michael Burnett, who's going to take us through the next presentation.
Yeah, we'll just hopefully get control.
Yeah, looks like it's working.
Yep. Okay. So, hi, as Steve says, my name is Michael Burnett, and we want to go through the work that we've been doing on catalysis, and this has been done in conjunction with InnovateUK. And so what we want to do in the time we've got is just go through some of the high-level conclusions and some of the recommendations coming from that. There's a lot more detail behind that, so we would like your initial feedback now, but also, get in touch if you want to know more. We can continue the conversation. For me, this journey started about 3 years ago, and it was prompted by our academic community raising the importance of catalysis and the potentially being this translational gap from research to commercialization. So KTN, along with InnovateUK, decided to start with a blank bit of paper and ask the question, what is this opportunity and where does innovation play a part? So there's been a big body of work that's been going on over this time frame, and that's ended up in the last section of this piece. We've been in the fortunate position to be able to commission an independent market study report on catalysis. And we've, amongst all the workshops, we also had an opportunity to go and visit a couple of European centres and to look at how they deal with industry-led approaches to research in catalysis. So one of the key things I think it's even been touched upon now is identifying that catalysis is going to be a key enabler for a lot of the technologies that will be needed to deliver some of the grand challenges, but it is one part. It's a cog in that system, and it's a key part of that system. But then it's a case of how do we approach catalysis to make sure we can translate research to commercialization. And what we've come with this, a lot of the work we've taken from all the inputs we've had, is that we need to be taking catalysis as a systems approach. We can get a lot of great science by looking at catalysis, but actually making commercially viable opportunities and understanding where those opportunities lie. We need to start looking at the complete system. bringing in the different parts of the supply chain, having a thought about what the feedstock is, what the end product is, what type of process is going to be involved, and making sure then the catalysis is designed to actually fit within in that, and so then you get an optimal solution at the right time, providing the answers that are needed. Now, when we went through this, what we got from companies is that when they start looking at this end-to-end process design, not only does it involve a lot of players, a lot of disciplines, because catalysis is just one piece of the overall problem, it can start getting a bit hidden and lost, especially if you're starting to look at trying to find out where novel applications can apply and how you actually take advances further forward. What we also get from this is that companies also want to be able to get access to capability around catalysis within the UK, but it's actually where it sometimes struggles is getting the access on commercial terms, which is relevant within the timescales they need. Companies want to be able to get in, want to be able to, they don't necessarily want to publish the information. They don't necessarily want to be producing scientific papers. They want R&D, which is going to give robust information, robust commercial, viable information that then can be provided in quick timeframes, and then they can move on with the overall project. We also then, when we start, again, specifically around clean growth, when we start looking at the technologies and the range of portfolios options there, is there's also a struggle there to actually demonstrate this new technologies at scale, on pilot and demonstration scale, which then sort of is a barrier to getting that additional investment. Within this whole exercise as well, we've actually looked at our own UK capability and mapped that out. And what we've got is quite good strengths, certainly from the academic base around catalysis design and synthesis, where we've got a bit of a gap. And when we start considering the systems approaches, when we start looking at the catalytic process design and integration, and within that, looking at the upscaling catalyst, so the form of it, the reactor design, how that fits and plays a part in the system, again, bringing all that information and having consideration of the process, how it runs, and what's needed to make a commercially viable solution is something where we've got this gap. As I said, when we started this, we decided to approach this from a point of view of a blank bit of paper. And so with our industrialists, with academia, through different interviews, workshops, we tried to build up a picture where we felt the UK had opportunities in UK catalysis, and this is the results of that. And when we're looking at opportunities, we're looking at where we can manufacture the catalyst, where we can utilize the catalyst and take advantage of the products we're manufacturing. And then we're also looking at the export capabilities as well of all those technologies. Now, I don't think that anything that we have on this is going to be of any great surprise, but it's great within the community saying where we're saying catalysis can play a part. It's great to see. So we've got opportunities under clean growth, aging society and future mobility, things that are already being talked about so far, you know, waste, hydrogen, CO2, but there's opportunities around pharmaceutical manufacturing and fuels, all underpinned by environmental requirements. What I've done on this slide, it's not exhaustive, but we've looked at where some of those big opportunities where catalysis again can actually be an enabler for the shift towards net zero as well. So that's come from our community. As I mentioned, we've had a market study report commissioned and the outputs of that. Now, there's quite a bit of information within that report. I'm not going to have opportunity to go through it. Equally, there's a lot of information on this slide. What I just want to draw attention to is this is the global catalyst market. Currently was worth $34.1 billion, and it's estimated to deliver an additional value of $15 trillion when you start looking at the downstream sectors that it enables. Now, this information is pre-COVID, but what we're actually seeing as well is the estimates there was catalyst market was continue to grow at 4.5% CAGR. What we're going to see probably is a drop down because of this a pandemic that we've had, but we then still predict that the market is going to continue to grow. When we start looking at the UK, we see the UK market is estimated at $433 million. That's, but when we start looking at what we can do for including what we utilize for ourselves out of our own catalyst manufacturer and what we export, it starts becoming a revenue of close to $1 billion. So overall, the UK market is small compared to the rest of the world, but it's still significant for what we do. And the next slide as well, I'll just bring that further message further to home as well. It's still significant. We are a player on that global stage. And even for the UK, again, pre-COVID estimates was that the catalyst market was going to grow at close to 3% CAGR as well. What all of this information really meant to us, and what we've seen, is that actually, you know, we're at a change of tide for technologies and energy vectors. We're going to see a market growing, and even with the market growth without intervention, we're seeing there's opportunities for the UK to leverage its own strengths domestically, get a better market share right with its domestic market, while also then exploiting the export of technologies and capabilities abroad as well. So certainly we are at that point where now is a good opportunity for us. As I mentioned, I was going to say, just demonstrate a bit more the value for the UK. That $433 million market for the UK is estimated to enable $188 billion market downstream from downstream sectors. And just an example around there, we look at refining, $100 million of the catalyst market, enabling $42 billion of additional revenue. So really, you know, Catalysis is an enabling capability. It's a valuable market, and we've got a point to exploit that and strengthen what we do. When we compare what we've done from all the workshops we did, from what we've done from our community basis, and what we compare what we've got back from the market study report, what we find again is this message that we should focus on areas where we can grow domestically and lead globally. So at its heart, what we have is the catalyst and process design. It's this systems thinking bit that we need to strengthen, we need to leverage, we need to be focusing on at its center. But then what we need to be delivering on when we think about systems, we've got these key areas: low carbon hydrogen, carbon capture utilization, waste, including biomass to polymers. These are key areas where we should be focusing on, and there's great opportunities for innovation. I'll touch a bit more on that in a moment, but there's also other opportunities around environment, fine chemicals, functionality for polymers, and so higher functional materials around polymers and rubbers, carbon efficiency, and then we've also got biorenewables as well. When we look at this is like, let's say the catalyst process and design, as I mentioned before, we've got to be looking at this as system. So it's really important to start looking at the catalytic process design and its integration. So when we start looking at how the catalyst is designed, how it performs, and what systems it's got to deliver, and what product we've got to make, all of that's got to be factored in, and we need that capability to focus on that to really allow faster adoption and application of catalytic technology. The example we have here is the Johnson Matthey steam reforming catalyst, where actually what the picture is showing is it's taken a long time to develop the shape of the catalyst, and each time that shape changes, it's increased productivity, but there's a time scale involved in that. We need to do things faster. We need to look at how we can enable that. But when you actually look at the specifics of the latest design, one of the key things that this design does is it handles the heat transfer problem, enabling the sort of the structure of the catalyst, the capability to manage the heats that are involved in associated with that. That's been a key change. But in terms of solving the heat transfer problem, which is not necessarily going to, you know, if you just look at the catalyst design on its own, might not really look at what those engineering problems are associated with it. But in so doing that, you've also increased the voidage, you've ended up in solving problems with the pressure drop, and also increasing activity. So this is just sort of, I'd say, sort of an example, try to show why is it important to really be thinking beyond just the initial catalyst design, and sort of getting commercial value from the research that's been done. I haven't got enough time to go into all the details, and we've touched upon this in some Pete's presentation. Now, we in the UK have got expertise in traditional hydrogen production, and we can leverage that to use catalysts for accessing blue hydrogen and green hydrogen. And that's going to help towards the net zero. But what I wanted to sort of draw together here is we need a systems approach when we're thinking about this, when we're trying to decide what chemicals we need, what fuels we need, and what feedstocks to use. We need to look at what's available regionally. We need to be able to decide how to bring that together. When we want to achieve the thermodynamics that need to be right, we need to achieve the carbon balance. We need to sort of combine hydrogen with CO2, with renewable energy to make the right chemicals. And we need to take that approach to make sure we get these commercial solutions. Now, what I've tried to show in here is where Catalysis in red is where Catalysis technologies could actually help and support the pathways. There's a lot there. It's really important. And this is just really saying this is somewhere where we should be acting as the UK. There are other options. You know, the innovation and the opportunity for making big step changes is within the last slide, but there are areas where Catalysis can make a step change as well. Around fine chemicals, we've got a strong pharmaceutical sector as well doing R&D. Within the market study, we can see there's lots of patents happening in that area of Catalysis. Again, working with agrochemicals, flavors and fragrances, there's a growing market there. And there's tools that they're using, high throughput experimentation, predictive modeling. They can develop those. The rest of the sort of sectors can take advantage of what's being learned there. Waste and plastics was dealt with on the last slide. Certainly, there's definitely an opportunity for what we need to be leveraging from a net zero point of view there. For the UK, beyond that, in sort of virgin materials, it's about the areas of polymers and rubbers where there's increased functionality. There's opportunities around carbon efficiency, and this is looking at existing processes, the existing capabilities we've got. A 5% change on certain key processes can have a big impact to the bottom line, and it can also have a big impact on environmental impact. There is opportunities within that. Environmental, we know that the regulation is going to tighten down on what catalysts we need automotively for the automotive industry, but as we change powertrains, we're going to see need for other catalysis capabilities as well. So there's about displacement of technology within that, but there's also increasing areas, smaller areas around clean air, water treatment that can be grown. And then also we've also got sort of the virgin bio-based feedstock opportunities. So there is a lot that catalysis can be used for, but our priority of where our recommendation priority is those net zero enabling ones from using hydrogen, carbon, and CO2, sorry, and waste to produce chemicals and fuels. So overall, what our conclusions come from this: a significant size market for catalysis and catalyst. It's growing. In the UK, it's sizable. It has a big impact for what we do here, and we're on a cusp of change when we start looking at where technology is going to be taking us and what we're going to be doing. But our biggest sort of opportunity right now is around hydrogen, let's say CO2 utilization and waste to chemicals. And so our recommendations for where we need funding, we need to lower the barrier to entry to our existing capability on catalysis expertise. It needs to be industry-led. It needs to match the timescales that industry need. It's got to be focused toward patenting rather than publishing. We also see, because we need the systems approach, we need collaborative R&D funding. And we need that to bring the supply chains together, to have the right conversations, to make sure that this key part of catalysis is designed to operate and work on the right process at the right time. Longer term, we know that we're seeing that actually demonstrating projects, we need to be able to have a look at how we can actually build some demonstrators, how we can get that capability, again, to demonstrate the commercial viability of these processes. Once we want to scale these things up. And also what we're seeing, again, we've seen the systems approach. I've mentioned this catalytic integration, process design and integration. We need to be looking at the capabilities we've got there and looking at how we fill that gap again to make sure we can actually translate these things through from design through to scaled up processes and actually do that. So that is overall our overarching conclusions. There's a lot of material that goes behind this that I haven't been able to go through, but hopefully that's given a good flavor of where it goes. What I'd like to do quickly now is just based on what we've gone through and what we've heard so far is ask you these couple of questions. What do you think are the most important priority areas? We've said what we think. The first question is multi-choice. If when the poll comes up, if you can actually just vote for your top 3, that would be great. And the second one then is what do you see is the most important funding that you see at the moment? And that's just a single choice option. So if I can give you 30 seconds, please, to answer that, I'd really appreciate your immediate feedback. Okay. Maybe give it a little bit longer. We've got a bit of a slow response. Okay, give it a bit longer. But in the name of time, we might just have to move on soon. So if you're still thinking, if you can quickly put your thoughts down. I think if we end it there and then. Okay. That's useful. Thank you very much for feeding that. We'll take that back through and we'll take that in. We'll compile that information. That's really useful. So if I just, I think if I've still got control, I think there's one more slide. Yeah, so the big thing here, again, there's a couple of us been working on this, myself and Sheena. If you want to know more, if there's feedback you can give us, then please get in touch. Don't let this be the end of the conversation. There is going to be a report of all covering all of this work. There'll also be a summary report of the market work that was done as well. Watch out for an article on Catalysis from the KTN website. If you haven't already done it, then the best way to make sure you don't miss this is to register for our newsletter, which can be done on our website. And Pete's already mentioned some of the activities that are going on in the different areas. Catalysis is a key component of all that other work. We need to make sure that we get involved and engaged. So please keep a look at those involved in those activities where Catalysis can play a role, and let's start building those projects and ideas and those interests. That's all I have to say. Thank you very much for listening. I hope that was useful.
That's great. Thank you very much, Michael. And thanks for everybody who's put comments in the chat box. I think Jeremy commented that, yeah, there's a lot of similarity and a lot of complementarity about these two presentations. Interestingly, they both started from a different point of view, but the end product, as you say, there's a lot of similarity. Also, I've noticed that Karen Hobbs, who I think has had to leave now, has put some information about forthcoming SCI events on there. So before we go on to industrial biotechnology, we've got a few minutes for questions.
Sure. Yeah. So we've got a few questions in the Q&A box. We'll just go through them. I think we've got enough time. So the first one is from Peter Fisk asking whether there's a need for cleaner, less toxic catalysts than what we currently use.
Yes. I mean, that was something that was identified in all the workshops across all different types of all the different sectors. People are identifying that was going to be a need. Certainly our approach when we've done all this work is we've encompassed all catalysis, photo, electro, biocatalysis. Actually, what I think in some cases is going to be interesting when we start taking a systems approach is it's going to require a combination of different catalysis to find the optimal solution. But certainly the less toxic options is something that people are interested in and are looking at, and it is part of the jigsaw puzzle.
Sure. Sheena, did you have anything to add to that?
No, thanks, Matthew.
All right, no worries. So Jeremy Shears is asking about future bio-based platform chemicals, because of course currently the petrochem industry is based on ethylene propylene. Does anyone have any thoughts on what the future bio-based platform chemicals might be, for example, lactate?
I'd have to go back to look at the information that we've got on that. I know we've got something. I'm not sure whether Catherine, Dana and Raj on the IB front might be in a good position to give their viewpoint on that once they get into their presentation. Sure,
we'll see if they cover that during their bit. So just to wrap up, a final question from the Rapid Innovation Group. What's your current thinking or position on biocatalysis? It looks like it could be cheaper, greener, and deliver greater yield than traditional chemocatalysis.
Yeah, again, as I've mentioned before, we're open with this body of work. We've looked at the biocatalysis, certainly the biocatalysis community, the IB community who've been involved in the work that we've done. And again, it's looking for what the optimal solution is, and making sure, I suppose the uptake of it requires you to look at what the commercial benefits are when you do adapt and switch technology. It's trying to look for those areas where we may be trying to do something, offer something above and beyond. I think there's definitely opportunities where within the catalysis community there's a sort of more of a multi-step process where you take advantage of biocatalysis at the lower temperatures, but then you move on to chemocatalysis. But the flip side of that within the work is that if you have to then start putting the energy in to do the chemical transformation, then you've also got to look at the overall energy balance that's required. So it requires us to, the collaborative approach that we want is to make sure those communities all work together to look for the optimal solution, and considering the sort of process engineering design that's needed as well, and making sure you get that sort of the best solution you can do. But certainly, biocatalysis needs to be part of the answer.
Okay, I think that's all on the question front. So,
okay, that's great. Thank you. Well, we're very much on time, which is amazing. So many thanks for that, Michael, and thanks for all your comments and questions. It's really helpful to know how you're thinking. So the next presentation is on what we're doing around industrial biotechnology, and it's going to be, there can be 3 people talking, Raj, Catherine and Dana, and initially I think we need to pass the control over to Raj to start.
Yep, I've got control. Hi, Raj Mistry, everyone. Yeah, we're going to tag team this section. So I'll start off gently by introducing industrial biotechnology and engineering biology. So these are 2 definitions I've pretty much taken from the internet, but to bring things into context, industrial biotechnology is all about using biocatalysts to process both materials and chemicals to intermediates and products. Engineering biology takes it an evolutionary step further. Simplistically put, this is where you build a biocatalyst from scratch, taking all the best functionalities of biocatalysts to facilitate a desired effect. So in terms of the UK bioeconomy, the UK bioeconomy strategy was published back in 2018 and pays particular emphasis on replacing fossil resources through bioscience, with 4 main goals to include leveraging UK's bioeconomy assets to maximize productivity, create the right socio-economic conditions to stimulate the uptake of bio-based products and services, capitalize on our world-class innovation base to grow the bioeconomy, deliver tangible benefits for the UK economy. The infographic from the strategy on the top right-hand side of the screen simply highlights how the bioeconomy feeds into different sectors and how it links to some of the global challenges such as food security, health, well-being, energy production, and the environment. It is also worth pointing out that at the time of publishing the strategy, the UK bioeconomy was worth £220 billion and supported 5.2 million jobs. So I guess the big question is, can we leverage UK's bioeconomy assets to address some of the net zero challenges? So to explore this further, let's revisit one of the previous slides presented by my colleague Peter. Two scenarios, the first of which is a fossil route to products. IB and engineering biology is already being utilized for greening processes. Scenario 2, switching out the fossil fuels for a more sustainable feedstock. IB and engineering biology could play a significant role in this scenario, from feedstock all the way through to the final product. It is unlikely that we are going to wake up one day and be expected to switch from scenario 1 to 2. There is likely to be a phased transition between the two scenarios. And again, both enabling technologies could play a part. This is depicted by the green overlay and is a real opportunity for our communities. Let's consider some of the knowns about IB and engineering biology, just to put things into context. Well, we use non-food crops and organic waste as feedstocks. A topic taking center stage is bio-based plastics, which is attractive from an emissions and energy savings perspective. Businesses and academia have portfolios of improved enzymes discovered either in-house or more often through consortiums around European projects. Microorganisms can reduce the number of steps to products or increase the number of chemical products in a single step. Both IB and engineering biology can complement or in some cases replace metal catalysts. Finally, lower temperature and pressures are inherent in bioprocesses compared to conventional processes. So it seems that the community are already in the driving seat in terms of greening and reducing energy demands on processes. The next natural step would be to turn our attention to net zero. So how are we placed and perceived? Please note, this is not an exhaustive list. It's mainly used as an example, and I don't want to offend anybody by not having their company logo on here. It's mainly to put a point across, and we are aware that this is just a drop in the ocean. Okay, so often IB and engineering biology are seen as disconnected technologies from everything else. But if we take a closer look, you will find two disciplines the two disciplines cross over into many areas. The obvious ones are, of course, DNA synthesis, biotech, health and pharma. The less obvious ones are data, software, machine learning, agri-food, chemicals, and is further supported by services such as high throughput screening, genomics, metagenomics, to name but a few. Gone are the days it would take years to find a biocatalyst. With these services in place alongside our academic base, businesses could have a trial catalyst within months. The BBSRC also need to be mentioned in this context as well, especially the NIBs, as they have a role to play, as most if not all of the projects have an underlying circular economy and sustainability theme. Also, we have key capabilities across the UK to include, CPI, iBioIC, BioVail, BDC, and amongst others. They play an important part also in terms of supporting both business and academia through the provision of equipment and expertise. And not to forget us at the KTN, we are here to connect the dots and facilitate those interactions that would otherwise not happen. So it seems obvious that IB and engineering biology communities are well placed to tackle some of the emerging net zero challenges. I strongly urge both chemistry and bio communities to seriously start thinking about net zero. For example, if you have a chemical process that could be re-engineered to adopt IB or an engineering biology or engineering biology, or you may have an existing technology that could provide a solution to other sectors. Either way, conversations need to take place, and the KTN are here to lend a hand and facilitate any interactions. All you have to do is ask and tell us who you want to engage with. On that note, I guess I'll hand over to my colleague Catherine, who will take you through some of the IB activities the Chem and IB team are involved with.
Brilliant, thank you, Raj. I think your dog was very excited about industrial biotechnology there, so good to hear. So, good morning, everybody. my name is Catherine and I'm the KTN for IB. My expertise is in scale-up, tech transfer and the commercialisation of IB. So nice to see so many of you online. I do recognise quite a few of the names, so yeah, good to see you. We're just having, if you can bear with me, there we go. So following on from Raj's talk, I'd like to talk to you about a great tool that we have developed within our team called a landscape map. And we have one for IB and SynBio. The links are given on this slide, so when the slides are circulated later, please do check them out. And what we try to do is capture all of the community in terms of tech providers, companies, academic institutions, there's training courses on there, equipment suppliers, basically anyone that's working within our community and you might want to contact, they're all on there. I'm going to show you what it looks like. So this is a screenshot. So if you click the link, this is the landing page that you'll get to. This is the one for industrial biotechnology. And if you click on each bubble, you will then get a list of all the companies or whichever bubble that you're clicking on and a bit more detail there. So if you're not on the map, and you would like to be on the map, please do contact Dana and myself. It isn't an exhaustive list and we probably have left some people out, not on purpose, but it's quite difficult. There's new companies coming up all the time. So please do get in contact and let us know. So really we envisage this tool as an enabler of collaboration. So it would be good, you know, if you could click on, see who's working within your space and in what areas they're working on. And if it's similar areas to you and you would actually like an introduction into that company, then Dana and I can do that for you. So yeah, please do use it. Just another note, that there are lots of landscape maps within the KTN for all the different sectors as well. There's a couple for chemistry, one for the process manufacturing. So it's not just IB and SynBio, but yeah, just for the purposes of this talk, I've concentrated on IB. So I'd also like to give you some information on an amazing EU project that we've been working on called KetBio. So KTN is one of 7 partners, and in fact I'm the project manager for this project. It's been running for about 2.5 years already. It's due to finish soon, but it's an amazing project around the commercialization of IB and there's loads of good information there. So it's an EU funded action and it really aims at speeding up the market uptake of biotech research results. And as a project, we've got 3 unique services. One, we have an online platform or an online hub, which is specifically designed for KetBio. And you can actually post your profiles on there. So not just personal profiles, but project profiles. So it's a bit like Facebook, but for IB. It's quite cool. And you can meet peers and industry within the biotech sector. We also have a commercial committee. Ben Hackle is actually on this webinar and he was actually one member of the commercial committee reviewing biotech research results that have come in, and then they actually offered their business recommendations and coaching. You know, that's an amazing service and I don't know any other project that offers that kind of thing. Also, we have an e-academy or a learning academy with loads of cool webinars and working groups. So you can actually go and check out everything that's been recorded on there, access at any time. So please do go and check it out. The best thing is that all these services are completely for free. So yeah, please do go and check it out. So in terms of what the KetBio mission was, it was really to identify the most promising and most innovative biotech research results from the EU. And it's interesting, there's been a sustainable aviation fuel mentioned in quite a few presentations this morning. And the winner of the KetBio project was FlexiJet, which is based on sustainable aviation fuel. So that's a theme that keeps on coming up. You can see the top 10 projects that were voted on the hub. Very interesting to see the main themes for biotech, which people really feel are going to make an impact in the future of the EU. So I'd say that the commercial committee is really the KetBio's cornerstone. And it's composed of 12 high-level people from industry from all around the EU, and that committee reviewed the research projects, and they've actually offered recommendations, tailored recommendations and contacts. So the winning project, FlexJet, have actually won an innovation accelerator program where we hope to get them over the next stage of their commercialization journey. We've also promoted loads of good discussions within the IB community on the forums. So we have topics of sector relevance, business intelligence, or barriers to market access, all being discussed there on the KetBio online working groups and in the webinars, all of which you can access. In terms of the themes, really we're focusing on industrial biosciences and bioengineering. As we all know, these sectors are vital to a sustainable circular economy. They really prepare the ground for the modernisation of industrial sectors and ultimately sustainable growth and well-being for all of us. So in terms of the cluster, we've got researchers, projects, networks, and companies, all from key enabling biotechnologies, who are all collaborating within the KetBio online cluster. So what would be the benefits of joining KetBio? I'd say it's impact and visibility for projects, new products, services, and partnerships. So it's really a good platform to get yourself known on there. And people do read the profiles, and we do have a lot of people contacting new projects for future collaborations for the new funding calls that are coming on. So if you are an IB project, a company, a spin out, an investor, anything to do with IB, the commercialization of IP, I really do recommend that you check the project out and put your profile on. So I've just put the website there for you. You can follow us on Twitter and also the newsletter. So there's 2 months left of this project. So yeah, I would check it out before the platform probably goes dormant. So I believe that I am going to keep control of the slides, and I am going to pass over to my lovely colleague Dana, who is going to be talking about her activities. So Dana, over to you.
Thank you, Catherine. Hi everyone. For those of you who haven't met me before, I'm Dana. I'm the Knowledge Transfer Manager for Synthetic Biology. And following on from Catherine, I really want to talk briefly about another project the IB team at the KTN is part of. And I briefly want to talk to you about it and make you aware of the project and ensure that you are involved in the project, especially if you are not using industrial biotechnology at the moment. So we have heard in all the previous talk about the importance of the bioeconomy and net zero. And I'm sure, or I hope we can all agree that industrial biotechnology plays a really important part to move away from fossil fuels and achieve our net zero ambitions. And when I talk about industrial biotechnology here, I'm always including engineering biology, because this is part of industrial biotechnology. So I want to talk about this bioeconomy cluster project, and communication is really important, especially talking to companies who are not using industrial biotechnology at the moment and who are not aware of the opportunities and the positive impact coming from industrial biotechnology. And this aspect is a really big part of the bioeconomy cluster builder project. So the project is a 3-year collaborative project between IBIC and the KTN. For those of you who don't know IBIC, they are the Industrial Biotechnology Innovation Center based in Scotland. The project itself is funded by the European Regional Development Fund, and KTN is a subcontractor in this project. And as I said, the aims of the project is really to increase the awareness around industrial biotechnology and increase the uptake of IB in Scotland. So we are looking around raising the awareness, engage with stakeholder, making them aware of the benefits of bio-based products. So thinking about sustainable feedstock and increase the overall application of industrial biotech, and also increase the numbers of companies working in industrial biotechnology. As we heard from Raj earlier, industrial biotechnology is a really broad field impacting lots of different aspects. So we are going to focus in this project on sectors and fields which are important to Scotland and also the wider UK. So we are talking about areas like waste, thinking about different biomass like marine feedstock, agri-tech. And as we heard from Pete, decarbonization is really important. Carbon capture is really important. So we will talk with stakeholders in this area to make them aware their opportunities to capture carbon dioxide and convert it directly into new chemicals and small molecules. So there have been some really interesting discussions on the chat about this area. Overall, the project is thought to contribute to the Scottish National Plan, drive innovation and ensure investment leading to economic growth, which will also benefit the UK in a whole. So we are going to have a launch event on the 23rd of July. It will be an online webinar between 2 and 3 p.m. on the 23rd. So please have keep an eye out for announcement coming out from the KTN newsletter and also from iBioIC. So I also want to talk briefly about our stakeholder engagement. Catherine, if you can move to the next slide, please. Thank you. Within KTN, of course, we are talking a lot to UKI, the research councils, InnovateUK. And there are also two stakeholder groups the IB team is really involved with. It's the Industrial Biotechnology Leadership Forum and the EBSC, which has recently renamed to EBSC and was previously known as the Synthetic Biology Leadership Council and is now known as the Engineering Biology Leadership Council. Both of those groups were formed in 2009 and 2011. And they were formed to establish and realize the industrial biotech and engineering biology strategies. For its membership, there are representatives from industry, UKI, base sitting on the group. The EBSC has also members from the academic background, and the EBSC is co-chaired by the minister from base. So we are having regular meetings with those groups to discuss current activities and highlight the most crucial issues from the community, and also we are supporting their activities. So for example, our former colleague Yvonne was heavily involved with the IBF and in the development of the bioeconomy strategy. I'm working relatively close with the EBSC and the chair, Lionel Clark, and really to look at how we can support the next step of engineering biology in the UK and ensure that the UK is a leader in engineering biology and that we are getting the commercial output from the excellent work the research centers are doing. The EBSC has an open meeting once a year, normally around November. So if there's any particular topics you guys would like to raise or you would like to discuss with the EBSC, please get in touch and we can discuss opportunities. Before I'm going to open up for the Q&A, I would like to highlight some of our activities coming up in the near future. So I already mentioned the bioeconomy launch event on July the 23rd. There's another event we have in the pipeline. It's on October the 7th, which is focused on opportunities for industry biotech and engineering biology in agritech. So the idea is to bring the stakeholders together so they can really understand each other's opportunity and needs. And the idea is to have collaborative projects coming out of this meeting. We are also looking at a biofabrication event in collaboration with the University of Nottingham. So think about 3D cell printing. What can we learn from 3D cell printing? How can it be used to, for example, test new drugs? So as I said, please keep in touch, sign up to our newsletter. And if you want to talk to us about industry biotech and engineering biology, please reach out. And with this, I'm opening the floor for a Q&A and otherwise handing back to Steve.
Can I just mention as well, before we hand over to Steve, for those of you who are interested in the application of IB to the net zero theme, we are going to have some questions on the feedback form. So we haven't done a poll on our presentation, but I would be really interested to know if you are an IB company or researcher with a technology that you feel is appropriate for net zero, so that we can contact you. So please do that. Over to you, Steve.
Okay, thank you very much, Catherine, Dana, Raj. Just to, I know there have been a few comments on the chat box about the KTN landscape maps, and it appears as though we may have chosen a day to do this when they've all been taken offline by our web team, who didn't tell us they were going to take them offline. We are going through a process of rebranding the KTN at the moment, and I suspect that's the problem. Bear in mind that they do exist, and they will be back one way or another. So apologies that if those of you who just tried and it's told you they're not there, they will be there. Any questions on? Let's we look in the Q&A box.
Yeah, got a question from Ryan about the cluster building project opening in July. So Ryan's asking to Dana specifically, would they have potential access to an iBioIC student, and would they have access to the equipment in both the SIPBS, not sure what that stands for, and at Heriot Watt?
I will pass that on directly to iBioIC and get back to Ryan about this.
Fair enough.
That's okay.
Yeah,
yeah.
That's fine.
Okay. Nothing particularly on the chat box apart from the fact that we can't get on the landscape map. So again, apologies for that. I think something I perhaps should have just said, because we've spoken earlier in some of the presentations about funding and requiring funding for, well, various things, loads of things. At the moment, clearly we've still got the industrial strategy and the challenges associated with that. Essentially, we've still got a new government, because essentially since this government's been in, it's been struggling with COVID almost the whole time, and how technology and innovation is going to be funded going forward, I don't think any of us are quite sure. But I think if we take our hints from all the sort of post-COVID bounce back funding that's becoming available now, then it's pretty clear there is going to be funding for innovation. I think the government definitely wants to ensure that industry can take advantage of innovation to help it come out of the COVID pandemic crisis in as healthy a form as it can. So we don't know exactly how the funding will be, but we do know that InnovateUK is making preparations for bidding for funding whenever and however it becomes available, and that's the reason why we're doing a lot of the work we're doing, so that we're actually ready to say, you know, the chemical industry is ready here, we've got some real needs, and we want we want to make a strong case for why funding should be put into this particular area. So that's just a general point. I'm just going to hand over now to Sheena, who hopefully has control of the screen.
Thanks, Steve. This just before we wrap up, we've just got a few future opportunities that we wanted to highlight. Matthew is going to talk about digitisation in a second, but we have some additional opportunities. So KTN's SME Accelerator should be kicking off in the autumn, possibly sooner. And if you're interested in hearing about that, please contact Pete. As was mentioned in the first two presentations, we are going to be running some brokerage activities around net zero feedstocks. And I've already seen in the chat box some really interesting challenges that would be great to have posed in some of those brokerage activities. So if you've got a challenge around your waste utilisation or more sustainable feedstocks that you're looking at, please get in touch with me. We'd love to hear those and see how we can put together some projects. Catherine and Dana are the focus for the bioeconomy cluster builder, as Dana talked about, and if there's any sort of future EU bio-based projects ideas, please get in touch with them. Before I hand over to Matthew, I'm just going to say we've got Meeting Mojo set up. I know some people are struggling to have their companies approved. That will be happen just after this session. Please set up meetings with us or email us and we can set them up after, but please take the opportunity to network with each other, and there's been some great chat in the chat box, so hopefully this has been useful as well. Just going to hand over to Matthew to talk about the digitisation, and just before everyone leaves, we have a final poll that we will run to give us some feedback. This has very much been an experiment today for us. It's the first time we've done it. Hopefully it's been useful. I think it has from the chat box. It looks like people have been really engaged, which is great. But if you could just, before you leave, fill in the poll to give us some immediate feedback, that would be great. There will also be a survey that will be circulated along with this webinar recording and the slides from today. So thank you for coming. Matthew, I'll hand over to you to talk about digitisation for a few minutes.
Thanks, Sheena. Yeah, just a couple of things from me, everyone. Matthew Reeves here, up in surprisingly sunny Edinburgh. So I'm focusing on the area of digitisation. So basically, I'm looking to hear from anybody who's interested in adopting digital tools in either their R&D processes or the manufacturing processes, or pretty much any aspect of your business functions. So by digitisation, I mean things like laboratory automation, simulation, analytics, modelling, AI and machine learning, inline process analytical technology, and things like that. We are putting together a going digital playbook at the moment that will be used to outline various roadmaps towards sort of fully automated design and manufacture of formulated products, materials, and chemicals. So as I mentioned there, the subtopics include laboratory automation and robotics, process analytical technology, sensors, Internet of Things, process control systems. And yeah, so we're creating this playbook for R&D, including case studies where we're looking to help companies understand what the opportunity is in terms of digitization and facilitate the interactions with the solution providers to accelerate the adoption of the tools. Later on in the year, we're looking to run a showcase event for digital tools in manufacturing. Back in February, we ran one for digital tools in R&D. And then we also want to run some road mapping workshops for companies looking to digitize. So again, if you're interested in anything here, if anything takes your fancy, please do get in touch with either myself or Michael, and we'll get you involved and keep you up to date with what's going on. So thanks for that. Back to you, Sheena.
Brilliant, thank you, Matthew. So yeah, that's us wrapped up a little bit early so everyone can get to lunch. But before we do, Shelley, can we launch the final poll, please? If you could just answer the few questions we've got at the end just about this session, if it was useful, how often you'd like to see it, and what content you would like to see in future. That'd be really helpful for us in planning the next sessions. So thank you so much for attending today. Hopefully you find it useful. The slides and the webinar recording will be sent around after this session. So if you could, fill in the feedback, that would be great. Thank you so much. Brilliant. If we could close the feedback poll, and just everyone else that's on the line, everyone has voted. Thanks so much. I think we'll close here. Thank you for your engagement. It's been a really great session. If you have any questions or want to talk to any of us, please do get in touch. You've got all our details. Thank you.
And thanks for me. Thanks you all for lasting out the, well, almost 2 hours. And as Sheena says, you can get in touch with us by email or whatever method you prefer. But thanks for coming.